So excellent. So Guido, the floor is yours. We are not able to hear you, at least on my side. I mean, you're unmuted, but I don't get to listen to you. And I was listening to Javier a few minutes ago, also Nicola, so it seems to be on your side, at least.
Okay, so I'll try to. Okay, I hope you can see now my screen.
Yes, we see your browser, right?
Okay, but let me try with the. Okay. Okay, it says loading. Okay, I think we're there. Okay, sorry for the delays. So I have to show you today, this is called TinyGS, which is a reduction for tiny ground station. And actually it's a public network and a community and collaborative network for getting LoRa packages from satellites. This is reverse to the communication that we are actually studying, which is direct to satellite. But this would be the path from the satellite to a node. So the idea here is to receive packages from satellites, and those packages, they usually have telemetry value, so it helps the network, and also it can be used to do some testing. So I had to buy a particular board. I'll tell you about that later. This is me actually here in Genoa, and my ground station is on the system. Okay, you can try with the web page of them or the project in GitHub. Everything is open source, so you can check out everything you want. Okay, so TinyGS, what is? It was founded by the FOSASat team. The FOSASat team is a startup company, very popular in Spain, because they started with the idea of Pocket Cube for LoRa communications and IoT communications. So actually this year they deployed, I think like 12 satellites in a constellation for IoT. So okay, this team, they also create this idea of TinyGS, but now they extend it to the open community, so other satellites are able to participate of this network, as is the case of one satellite from Argentina, the MD QSAP. Again, I'll tell you later. So we was the idea to able to track and use satellites for learning and experimenting about radio. And okay, it also benefits the satellite mission because you're able to recover telemetry for all around the world. So as much TinyGS stations we have developed, the more telemetry we can get if we are a satellite and we want to do some testing. And it might work like a Class C LoRaWAN because the end device is always in reception mode. And it only supports the ESP32 boards with these chips, which are pretty old right now, but actually, well, that's how they work right now. Installation is very easy. They have a program to do that. It's quite easy to do. And they use the MQTT protocol for exchanging data between the end device and the network. So you don't have to do nothing. The network, it only change the parameters of the LoRa regarding the new satellite that it's coming to the network. So you don't have to do nothing but put your end device connected to the internet, and everything happens do the MQTT protocol. Also the firmware update if it's possible. So the code from the microcontroller is always also available. I can share the screen if you want later. So what about my receiver? I bought this one. It's a Heltec Wi-Fi LoRa 32 version 2. The link is here. It's among almost $20 the cost. It has an IPEX connector. You can see some screens here. It has not support for the new modulation of LoRa. I think this is important to tell. But if you want the new modulation, we have a version of the Heltec CubeCell. This is the one that it's been used for testing, I think, in this company from Argentina, InnovaSpace. They are working on IoT and they have this one as testing and devices, I think. I mean, they're very popular. But you can
There is no
see,
satellite
yes.
in orbit, right? There is no satellite in orbit now transmitting long-range frequency hopping, or is there?
The only I found was from Lacuna Space, but they do not a public transmission, but a private solution they offered in some coast areas, I think in New Zealand or Australia, and they were using the new modulation with the LR 110 chips, the tuned chips from Centage. I mean, these chips, they don't have GPS, but the new chips from Centage, they do. But okay, you have internet, I'm sorry, you have a GPS, external GPS on the board, but not inside the chip. So actually these chips from Centage, they are not quite new already, but they support by firmware actualization the new modulation. So maybe we can try with this. Okay, then you have a bot for configuration in Telegram. So as I told you, it's very easy to configure the end device. Okay, now I'm telling you about my case, how was. So I'm in Genoa, and all the testing that we did was facing the east. So this was kind of the line of sight that we have. All the passes that we were expecting were from south to north, but in this direction. And then we changed the board here in the lab, but I wasn't able to have new packages. Okay, we have to develop our own antenna. We don't have many resources here in Italy, but we did what we could. This is a handmade 1/4 grave ground antenna, and it's actually worked very good. So now I have some results to show you. For example, as I told you before, all the receptions that we have were in the east. So this is because the balcony was placed facing the east. So we had clear sky at the east, but not the north or south or west. So, I mean, it's coherent to find all the receptions in this area. So the red dots doesn't mean the package was incorrectly demodulated, but maybe there's some misunderstanding between the data that TinyGS was able to retrieve against the package that they were expecting. So you don't pay attention very much at the red dots because they don't mean it was a bad reception actually. So we're able to receive up to 66 receptions, so that's too much, I think. The only satellite that we were able to receive were the Norby, which is a satellite, a 6U CubeSat from the University of Moscow. They were using the chip SX12878, which is the same as I have in my transceiver. The Fosasat constellation, they were 13 picosat constellation, or Porcecute. I don't know which is a chip, they don't bring that information. And there's another satellite, the FIS. I don't know, it's an Italian company, but I don't know the chip they were using. But well, the Norby uses a secondary payload, so they give this information because it was not the main goal of the mission. But this is the most important satellite on the constellation right now because of the transmission power they're using. So many of the stations are able to catch it. There are more satellite partners like these Argentinian Picosat, as I told you before. They are participants of the networks, but you're not able to receive transmission. I don't know if they had some problem of the satellite, or maybe with TinyGS or whatever. There is not very much info. So I want to show you an example. This is a very interesting part. For example, these are 3 packages I was able to decode. The distance and the elevation is estimated by TinyGS. You have to input the coordinates of your ground station, and they do all the calculation with the satellite PIs. They know, they have the information of the satellite, so they are able to estimate this distance. And perhaps Norby satellite uses spreading factor 10, so the minimum SNR is -15. And this is important because I did some estimations about a reception. And as you can see here, for example, let's consider this package. So the RSSA is -118, and the SNR was -7. As -7 is better, is upper the -15, this package was able to be demodulated. So yeah, actually it was demodulated. And well, I tried to estimate the noise. I found this solution by considering 6 dBm of noise figure. I don't know the noise figure of my receiver, but you usually use this number, this value. The bandwidth for this transmission was actually 250 kilohertz. And we can see it's almost fine, because if you do the subtraction between these 2 values, you're almost there, like 150 or 110 dBms.
Guido, this is uplink or downlink?
This is this should be downlink, but this is a reverse communication. I mean, the expectation for this kind of network is the end device to do an uplink to the satellite. Okay, but here the scenario is different. Is the satellite is transmitting a beacon all the time, so you are acting like a a ground station. Is the reverse path.
Okay.
So it would be like receiving a beacon from the satellite, but this beacon has some information about the telemetry. So you decode that information and post it on the TinyGS server with the information regarding the satellites. But it could be like an uplink in the scenario that we consider for LoRa. I don't know if I answered the question, Sandra.
Yes, thank you.
Okay, thanks. And then, well, I tried to estimate the RSSI using the free path law. Okay, this is an invitation to improve this, because I found in a difference about 12 dB. So there's much to say here, but not considering other attenuations and losses by the connector, the impedance of adaptation, the frequency shift, delivers to a difference of 12 dB. So maybe it is important to study channel modeling on this kind of networks to have a better estimation of the channel condition. So that's something to say anymore. I mean, I'm not close the value I was expecting. So I may say that this simple modeling is not enough to predict a LoRa satellite communication, maybe. Okay, but the noise, it was well estimated. Okay, what happened with the Norby satellite? Recently, Norby reduces the transmit power from 7 watts to 2 watts. So as you can see in the link budget, I was using 38.45 dBm. Now it's been reduced to 30, I think, 30 dBm. Okay, a little bit more than 30 dBm. But the budget loss is 6 dBm, and those 6 dBms makes that I'm not more able to recode any more satellite receptions. I should do some changes on my receiver, like changing the antenna maybe, or putting some low noise amplifier at the reception. But okay, no more package for me. But anyway, Okay, I was able to decode when they used to transmit at 7 watts. And okay, the system also offers an API, so you can get all the information from your ground station and do whatever you want, like some statistics. Here is an example of developing a Grafana server and make some statistics with the data. Well, we changed the antenna, but with no lag. This is my view from the laboratory. Okay, I tried to get these passes from today, but I wasn't able to. And I'm using this software called GPredict to face and to understanding where the satellite is in every moment. And maybe TinyGS is using this information to change in my receiver the new LoRa modulation, the new LoRa configuration for each satellite as they change over time. Okay, I was planning to show you a little bit of this tool, which is open source too, but I have a problem in this machine, so I won't be able to show you a demo. But it's a great software. Maybe you already know that. But you have plenty of information about the satellite paths and the elevation, and you can construct this with the information from TinyGS, and it's actually pretty much the same. So there are a lot of things to do. And okay, just to end my presentation, thanks so much. And if you want to contact me because you want to try this TinyGS solution to do some experiments, okay, you can talk to me, and I will so pleased to help you. Okay, thank you. That's all.
Thank you, Guido. This was really interesting. One quick question on my side. So you mentioned that maybe TinyGS uses this GPredict to understand which is the satellite that is on range at different moments, to change the modulation, but the reception parameters to basically get synchronized a given downlink frame, I think. Are you sure this is the way, or is the receiver in continuous scanning for all the frequency range and just parse any frame that arrives in that frequency range?
Okay, no. The key is on the MQTT protocol, actually. As I told you, you need full internet access. So through the MQTT protocol, TinyGS, let's say they have a server, and they are changing your configuration with this protocol all the time. So they have the database. They provide the TLE of all the satellites in the constellation, so they are able to predict where the satellite is. And they use zones. They do not send this information actually to every single ground station, but in fact they use like a Europe region, let's say. So you have the Europe configuration if you are in Europe, or the South America configuration if you are in South America. But you don't have to do nothing. You only connect this device to the internet.
So you plug in your TinyGS to internet, and via MQTT, this mini ground station gets updated from a centralized server that someone manages for you, basically. Okay.
Yes. That's right.
But that's interesting. Excellent.
But of course, you are able to do it manually if you want it. You can change the parameters on your own. Maybe you are interested only in the Norby satellite, so you put the configuration for the Norby satellite. The device will be all the time waiting for a reception. But yeah, it will be all the time in reception mode. Yes.
Yeah.
You can try actually to do some transmission as testing too, but the main idea of the firmware that they offered is to put it as reception mode only.
Excellent. Any other question from the audience?
I don't have questions, but I just wanted to say that this is pretty cool. I had no idea we could try getting some LoRa packets from satellites right now. So I think this is going to be very useful for having some information about maybe to complement what Tomas did for the channel modeling, but also for So Rodrigo is checking. I don't know if Rodrigo is there, but he's checking for the way to connect these devices with native IP. So using fragmentation and compression of IP packets, so that we can actually have like an IP address in the LoRa device. And having this info is very useful also for that part. So thank you, Guido, for the presentation.
Okay, thank you, Sandra. Yeah, it should be really interesting to make a better antenna, I think, and to put it on a better placement, because that's my plan for Argentina when I'm coming back.
Yeah, and we could try to replicate what we know that works also in Chile, so that we have several points for getting information.
Okay,
Hi, Sandra.
because
Hi,
it's very
Guido.
interesting. Yes.
No, sorry, I don't have a problem with replicate the scenario. Okay, I don't have problem.
We can try that. Okay, yeah, we can actually try. There are no many stations in South America actually, so it would be very good for the network to put some information there, also for the satellites. So yes, yeah, we can try.
Let's have one ready for the workshop.
Okay,
Can you ring
Yeah,
it?
we could try that.
Can you ring it to the workshop actually, right? It's just a little piece of hardware, right?
Yeah, it's very tiny actually. It's very tiny. So yeah, of course.
Let's bring it.
We can do some testing, or maybe, yeah, why not? Why not?
That sounds good.
All
Okay,
right.
thank you so much.
Okay, questions or comments?
No question for me. It was very interesting, and I will be very interested by the slide to take the figure and have a look deeply on it. It's possible.
Maybe I can share you the slides, Juan, and then you send to everyone.
Yep, sounds good.
Thank you very much.
Okay, yeah, you're welcome.
It was very interesting, and perhaps we will try to do it, or very good.
Okay, thank you so much, Pascal.
All right. Then maybe the last item I have on the list is to define a next meeting. So should we be meeting in 2 Fridays or 3 Fridays? What's your agenda looks like?
Let me see.
2 or 3 seems to be okay for me. It's holidays in France, but I think I will still work at this moment. 2 weeks or 3 weeks should be okay.
Okay.
It's okay for me in 2 or 3 weeks as well.
Sandra, you have any preference?
Let me see. No, that we're talking about this is the August,
Right.
the 12th.
5 or 12, yes.
I'm available both Fridays.
All right. Then I suggest, if there is everyone's flexibility, and since we have the workshop coming, maybe just meet on the August 5 and just check if everything going as planned.
That's
okay.
Yes.
Okay, perfect.
Maybe we don't need to have a talk and use the full hour, but maybe we can just quickly check that we are on the good path. This should be the same time, so I still this 3 p.m. Central European time. That's correct, right?
Yes, for me.
All right.
Perfect.
All right. So appointment sent. So then we only have left. You share the slides, Guido, or you can either share it directly to the whole group on the appointment. You have the emails of everyone, or you can send it to me and I do that afterward, as you please.
Okay, no, I can answer for everyone. So yeah.
Right.
Thank you.
And I don't know, any other topic that to touch today before we finish?
Not from my side.
All right. Well, so I wish you everyone a very good weekend and meet you in a few weeks.
Okay.
Thank you.
Perfect.
Thank to you.
See you. Thank you.
Bye,
Cheers.
everyone.
Bye.
Thank
Bye.
you.
Thank you.
Bye-bye.
Goodbye.
Bye, everyone.